My name is Kevin Sorochan. I'm presenting variations in North Atlantic right whale food Calanus species in the southern Gulf of St. Lawrence. Co-authors on this presentation are Katie Brennan, Catherine Johnson, and Stefan Plord. This picture is showing the three different species of Calanus in the Northwest Atlantic. C. hyperboreus and C. glacialis are Arctic species, and C. finmarchicus is a subarctic species. These species have both active and dormant phases in their life cycle. The active phase occurs at around the time of the spring bloom. At this time, individuals are in the upper water column feeding, developing, and accumulating lipid. When conditions become suboptimal for growth, the dormancy phase is initiated, which is associated with an ontogenetic vertical migration to depth. The three species have different characteristics in their life cycle. Hyperboreus is a capital breeder, initiates diapause at the fourth copepodite stage, and has a multi-annual life cycle. C. finmarchicus is an income breeder, initiates diapause at the fifth copepodite stage, and has an annual life cycle, but can produce multiple generations in a year, which can extend the period of active development. The southern Gulf of St. Lawrence is an expansive subregion of the greater GSL and is characterized by a relatively shallow bottom depth that prevents the persistence of diapausing copepodites throughout the year in high abundance. This effectively makes the region a Calanus sink that is dependent on immigration from upstream. This immigration is restricted to certain times of year when there is active development, which differs between Calanus finmarchicus and Calanus hyperboreus. And finally, the shallow bottom depth increases the availability of Calanus to North Atlantic right whales when foraging by restricting the bottom depth of the diapausing copepod layer. North Atlantic right whales have been monitored in the GSL for several years now, and the southern GSL appears to be an important area for right whales. Right whales occur in this area each year, and they persist within the area for several months. Monthly variation in confirmed North Atlantic right whale visual observations in 2018 is shown on the left, and daily variation in acoustic detections off the Gaspé Peninsula from 2011 to 2018 is shown on the bottom right. Passive acoustic monitoring in this area has indicated that the daily presence probability of detecting a right whale vocalization increased from June to September, followed by a steep drop-off. We conducted a zooplankton sampling field mission in October 2018, and this is around the time of the year where right whales are decreasing in their prevalence in the southern Gulf of St. Lawrence, but this did not affect our goal, which was to infer processes that are driving variation in abundance of Calanus in the region from the patterns that we observed. The sampling domain is shown in blue here on the left, and we did some repeated sampling in this red box that you can see. And the right-hand map here is showing the different sampling locations. We measured abundance of zooplankton at 24 locations and the vertical distribution from a subset of the locations shown in red. We measured the vertical distribution of Calanus using a depth stratified plankton tow system called the BioNES, as well as the video plankton recorder, which is a towed underwater camera system. These are plots of the vertical distribution of Calanus species, all species combined for the VPR, as well as C. finmarchicus, mostly from the BioNES. And so we have the legend of the different C. fin stages shown on the right. And then we also have a vertical profile of temperature. So the main take-home messages here are that there is a wide spread of Calanus throughout the water column at this time, and that the C5 stage, which is a preferred lipid-rich prey item for North Atlantic right whales, looks like it's being recruited to in the active population and near the surface, and looks like there's also an established diapausing population at this time as well. Now I am showing the vertical distribution of C. hyperboreus and glacialis, with glacialis in warm colors. The main point here is that there is a strong contrast between the vertical distribution of Finmarchicus and these Arctic species, with the Arctic species present mostly below the thermocline, with the exception of station 6.6, where there does seem to be an abundant near-surface population. I would also note that C. hyperboreus and glacialis are much lower in the magnitude of abundance at this time in comparison to Finmarchicus. These are more examples of variation in vertical distribution taken from a site that we sampled repeatedly over a period of approximately 24 hours. I'm not going to go into a lot of detail on the variations here, but I just wanted to provide some more examples that drive home the fact that there are different vertical distributions between C. finmarchicus and the Arctic species. We also observed variations between C. finmarchicus and the Arctic species in horizontal distribution, with C. finmarchicus being widespread and fairly evenly distributed in comparison to the Arctic species, where their centroid of their distribution, which is shown at where these two red lines cross, that has been shifted towards the east. These results are consistent with a separate analysis of the spatial climatology of C. finmarchicus and C. hyperboreus from zooplankton surveys conducted by DFO in September or October. Lighter colors indicate higher abundance in log space when averaged in these different polygons. We did particle tracking simulations to see if transport could help explain the horizontal variation that we observed from our field mission and provide additional insights into the processes that are happening at this time. So in these simulations, individuals were released from these red boxes and they were tracked for a 15-day period, and their final position is shown in purple. The black is indicating the trajectory of the particles. In October, the flow regime seemed to switch to a high displacement type scenario where particles were advected from west to east across the domain. And this is indicating that there could be high losses of active individuals at this time. I'm going to point your attention to the Bredell Bank simulations, and in September this area was actually characterized by high retention, but this was not the case in October. Our interpretation of the analyses presented here is that in autumn, supply of Arctic species is low, and their observed elevated abundance in the central area is due to retention of individuals that have immigrated in spring and summer. On the other hand, C. finmarchicus continues to be supplied to the region by transport and local production, which contribute to their widespread distribution. These analyses improve our understanding of the dynamics of supply of Calanus and ultimately the suitability of North Atlantic right-whale foraging habitat in the southern Gulf of St. Lawrence. Thank you for listening, and I would be happy to discuss any questions that you might have.